Let's talk about some properties of inverse functions that are really important and you really need to know. Now, here's the first one that is really cool. The range of f is the domain of g, and f and g are inverses. So essentially, the range of the original is the domain of the inverse, and the domain of the inverse is the range of the original. They're flip-flopped. We're going to use that in a second to find range by hand, which we've talked about in previous lessons is kind of hard to do. It's easy to find the domain by hand. We just do denominators and even roots. Finding range by hand is a little more difficult, and this gives us a way to do that, and I'll show you an example of that in just a second. Next, if point AB is on the graph of f, then point BA is on the graph of the inverse. This leads us to a very important rule about graphs of inverse. If this is the graph of your original, this would be the graph of your inverse. And that should show you that graphs of original and inverses are symmetric across the diagonal line y equals x. So here's my diagonal line, y equals x. Graphs of originals and inverses will always be symmetric. They will mirror each other across that diagonal line. And we can use that to do some pretty cool things. So, for example, here's a graph. I want to find the graph of the inverse. So I'm going to sketch the diagonal line, y equals x. And now I'm going to reflect this graph across that line. So if I reflect it across, make it mirror, I can see that the graph of my inverse is going to look something like that. Because these two things are reflections across that diagonal line, which is a pretty cool thing that they all have in common. They'll all reflect across this line. Now, in the next video, we'll talk about actually finding an inverse equation, which should probably be familiar. You've done this in the past, even though it might have been a little while since you've done it.